These are the section 3.4 notes, function operations. This is page 1. So pretty much a review on the front page. We are going to combine functions using algebraic operations. We are going to focus, though, on what happens with the domain. So example 1, we've got a little review of the domain. If we are not talking about a function that is modeling a real-world situation, the domain is always the largest set of real numbers for which f of x has a real output. Okay? So the only two places we really get concerned are where we have division by 0 or we are looking to take the square root of a negative number. Neither of those can happen. So A, we have a polynomial function, x squared plus 3x minus 17. Best way to think of this is we can plug in anything we would like for x. So our domain here in interval notation is all real numbers. We can go from negative infinity to infinity. B, we've got a variable in the denominator. So now we were in that situation where we could potentially have to divide by 0, which we don't want to do. Factor the denominator, we know x cannot be 7 or negative 7. In interval notation, we go from negative infinity to negative 7, and then negative 7 to 7, and then 7 to infinity. So everything except for negative 7 and 7. H of x, we're looking at that situation where we've got the radical. We know we cannot take the square root of a negative. So we set this up so that we can solve for the x's that give us non-negative values. X here is greater than or equal to 3. So it's the interval from 3 to infinity. We can include 3, so we do have that square bracket on that value. Example 2, we've got two functions, f of x and g of x. F of x is x squared minus 4. G of x is 1 over x plus 3. A, we want the domain of f of x and g of x. So the domain for f of x, again, it's a polynomial. It's all real numbers. For g of x, x cannot equal negative 3. So we've got negative infinity to negative 3, and then negative 3 to infinity again. We've got parentheses on the negative 3. We can get as close as we want to negative 3. We cannot use that value. So we want the sum, f plus g of x, and I'm going to write that out. This is not f plus g, then times x. This is shorthand for writing f of x plus g of x. Because the mathematicians are lazy, we save a set of parentheses and an x value. And that's pretty much it. So there's my f of x. There's my g of x. The domain still is going to be the most restrictive. So look at this sum. The x squared minus 4 part is fine. We can plug in anything there. The 1 over x plus 3 is still going to cause a problem for us. We have the difference of our two functions, f minus g of x, which is f of x minus g of x, and x squared minus 4 minus our 1 over x plus 3. Again, our domain is the most restrictive part, and that's that negative infinity to negative 3, union negative 3 to infinity. Everything but negative 3 still makes this work. And the product in the domain of the product. So we've got f g of x, which is f of x times g of x. Our f of x is x squared minus 4. Our g of x is that 1 over x plus 3. x squared minus 4 over x plus 3. Our domain again, negative infinity to negative 3, and then negative 3 to infinity. F times f of x. So f of x times f of x, we got x squared minus 4 times x squared minus 4. We multiply that out, we get x to the 4th minus 8x squared plus 16. Again, this is a polynomial. Our domain is all real numbers. So quotient here, and this is where we may have a bit of an issue. We've got f over g of x. So f of x over g of x. X squared minus 4 divided by 1 over x plus 3. I'm going to write this out once, just as a reminder. So we got x squared minus 4 times x plus 3 over 1. We get x squared minus 4 times x plus 3. X to the 3rd plus 3x squared minus 4x minus 12. Notice that the final version is a polynomial. We really have no issues with the domain here, but we do need to go back to the beginning, and this x plus 3 in the denominator is going to be an issue for us. So our domain here still has to accommodate for the fact that we cannot plug in negative 3. It's going to create an issue in our denominator. If we go the other way, g over f of x, I have 1 over x plus 3 all over x squared minus 4. Notice what this is doing here. I've got the problem with the negative 3, the denominator in the numerator. I also have an issue now with that x squared minus 4. So the 2 and negative 2 that would make that 0 gives us a 0 in the denominator. So here, this domain is going to go from negative infinity to negative 3, negative 3 to negative 2, negative 2 to positive 2, and positive 2 to infinity. That's basically just saying we cannot use negative 3 or plus or minus 2. So when I simplify this, 1 divided by x plus 3 divided by x squared minus 4, we end up with 1 over x plus 3 times x squared minus 4. We could really multiply that out so that it looks like the other one, but there really is no reason to. I am gonna, though, go ahead and move this on over. Oh, that was not what I wanted to do. So we'll go back, see if we can get a little cleaner here. And just move this domain so that it is next to its function. Awesome. See if I can color coordinate for you. And so we can match up what's going with what. Again, our issues with the domain are always going to be dividing by 0. That's always a no-no. And then whenever we have a radical, cannot have that negative under the radical.